Okay, continuing with chapter 1, we're on 1.7. This is going to be function combinations and compositions. So we've got domains. I told you we were going to talk a lot about domains. Implied domains, you will need to be able to determine the domain of certain functions by simply looking at the calculations in their formulas. These are all our polynomial functions. They have no domain restrictions based on their formulas. The reason is there are no math laws that we're going to break. We're not dividing by 0 and we have no square roots. So right here, our domain is all real numbers. If they ask us to do that in interval notation, it's negative infinity to infinity. The only thing, again, we can't break any math laws. We're multiplying and we're adding. There's nothing to worry about. Here, again, same thing. We have multiplication, raising things to the third power. We have subtraction, multiplication, and addition. We can't break any math laws, so the domain is all real numbers. And here you just have a constant, okay? So again, not breaking any math laws. The only laws you can break is if we're dividing by 0 or square root. Okay, so on all of these, there's no dividing by 0 or no square roots. Okay, and that's why it's all real numbers. Well, then we've talked about rational functions. Here, we can't have 0 in our denominator. So restriction is you can't include any values which cause the division by 0. So what we would do is we would take our denominator and set it equal to 0. And then solve for x. I'm not going to show my work here because we've been doing this for a while. We're going to take the 8 to the other side. So we're going to subtract it. Then we would divide by 3, so we get negative 8/3, okay? Again, I subtracted 8 divided by 3. So x cannot equal a negative 8/3, because if it does, we have 0 underneath, which makes it undefined. So how do you write this in interval notation? Well, here is negative 8/3. We would have a hole here. But it can be anything this direction to the left of it, and it can be anything this direction to the right. So what we would do is we first write this part in interval notation. So that would be negative infinity up to negative 8/3. Now if we do not want it to include it, we make it a parenthesis. That takes care of all of these values. Well, we also have all of these values. So we're going to take out that negative 8/3 by having a parenthesis and going to infinity. And you just put a union symbol between it. And that's how you do it. Right here, well, if I set this equal to 0, take 9 to the other side. This is just one way. You can factor it if you want. So if I take the 9 to the other side, it becomes positive. Then I take the square root of both sides. I'm going to use the square root property. I get x is equal to a positive 3 and a negative 3. Positive negative 3. X cannot equal that. Because if it does, we have 0 in our denominator. We have negative 3 here, we have 3 here. Negative infinity to a positive infinity. Hold on, I've got an alarm going on. I'll be right back. Okay, so sorry about that. We're going to have an open circle here. We're going to have an open circle here. It can be anything but those. Okay, so what I'm going to do is it can be anything this direction, it can be between these two, and it can be anything over here. Now, when I do that, to write this part, it is negative infinity up to -3, parentheses. Then that takes care of this part right here. Well, then I've got to take care of this part. To do that, it's from -3 to 3. Put a union symbol in there. And then now I do this part. So 3 to infinity. That's how you take out two numbers. That's how you write it in interval notation. Now, over here, this one is going to be all real numbers. And the reason for that is at this point, if we take this and set it equal to 0, some of you are going to say 3. Well, if I square 3, I'm going to get a positive 9. 9 plus 9 is 18, not 0. Well, then you might say a -3. Well, -3 squared gives me a positive 9. 9 plus 9 equals 0. So some of you are going to do this, and you're going to say x squared equals -9. Then you're going to take the square root. But remember, we can't, at this point, take square roots of negative numbers. Besides, when we talk about domain, we're only talking about real number restrictions. Real numbers, not imaginary numbers, okay? So that's why it is all real numbers, and we write that as negative infinity to infinity in interval notation. Okay. Radical function. We can take the square root of a positive. We can take the square root of 0, but we cannot take the square root of negative numbers. So to find our domain here, remember, and here, this is the other thing, you can't take an even root of a negative value. Excuse me. You can take odd roots, but not even roots, okay, meaning square root, 4th root, 6th root. All right, so what I'm going to do is I'm going to take what's underneath that radical. It can be greater than or equal to 0, and it'd be fine. Because if it's greater than, then it's going to be positive numbers. But it also can be equal to 0, so because I can take the square root of 0. So I'm going to take the 10 to the other side, so I get x is greater than or equal to 0. Well, again, the only reason I'm showing you a number line is because some of you will have a hard time writing interval notation. It makes it easier. So it's a closed circle because it's equal to it, and it's everything to the right. And I didn't mean to put 0. This should be 10 because I took the 10 to the other side, right? So this is 10. All right, closed circle, so it's a bracket, 10 to infinity, and it's parentheses. Right here, we can take cube roots of odd numbers. I'm sorry, let's try this again. We can take cube roots of negative numbers, 0, and positive numbers. So there is no restrictions here. When there's no restrictions, it's all real numbers. Now here, this one's a little bit different. And the reason, now remember, if you ever see a square root, you set it equal, and you're trying to find the domain, you take it greater than or equal to it. But the problem with putting it equal to 0 is because this is in the denominator, we can't have 0. So in order to find this, normally, if it was in the numerator, you take the 2x minus 5, set it greater than or equal to 0. But because this is in the denominator, it cannot be equal to 0. It has to be greater than 0. So now you solve, take the 5 to the other side, you get 2x, you added the 5, so you divide by 2, and you get x is greater than 5 over 2. Well, put that on a number line. Here's 5/2. I don't know why I didn't put it in the middle, but oh well. Here's negative infinity, here's infinity. So it is an open circle at 5/2, and it's everything to the right. Don't forget though, if this had been a negative and we divided by a negative, our symbol switches, but it wasn't. Open circle, so it's a parenthesis, 5/2, it goes to infinity, and it's parentheses. Okay. Next page. Combining functions to make new ones. Okay. Combining functions to make new ones. Using addition, subtraction, multiplication, division, you can create a new combined function from any pair of functions. Okay. So we're given two polynomials. And so we have to determine what it gives us when we add these two together, multiply, and then divide them. Now, then we're going to find the domain of them. So the first thing we have to do is, the nice thing is when it's a polynomial, there's no restrictions. So if we add these two, what this means is you take your f of x and you add it to your g of x. So this gives us 3x minus 7. Your g of x is x squared plus 6. Now you just put it in order. Your f plus g of x. You have x squared plus 3x. And a negative 7 and a positive 6 is negative 1. No domain restrictions. There weren't any up here, and then when we combined them, there wasn't any in here. So our domain is negative infinity to infinity. All right, well, we're going to multiply them. So you're going to say f of x times g of x. So our f of x is 3x minus 7. Our g of x is x squared plus 6. Now you just do FOIL. That gives us 3x squared. 3x times 6 gives us 18x. Let's try this again. 3x times x squared gives us 3x cubed. 3x times 6 is 18x. Negative 7 times x squared gives us negative 7x squared, and negative 7 times 6 is negative 42. Now all you have to do is put this in order, in descending order as far as your exponents. So our new function, f g times g of x, is 3x cubed minus 7x squared plus 18x minus 42. Again, we started out with two polynomials, and we ended with a new polynomial. Not breaking any math laws. We're not dividing by 0, or we're not dividing by anything, so we don't have to worry about our denominator being 0. We have no square roots, so we don't have to worry. Now this, however, it says f of x divided by g of x. Okay, we have division, so we're going to have to worry maybe. Okay, our f of x was 3x minus 7, and our g of x was x squared plus 6. Now, normally you have to worry about our denominator being 0. But remember, if I set that equal to 0, I'm just going to do it over here because, again, it's not going to affect anything. If you have this, you're going to have x squared equals a negative 6, and then take square root. You can't do that. So, again, our domain is all real numbers. Negative infinity to infinity. Now, however, had this been a minus 6 if it had been a minus 6, okay? It wasn't, but if it had been, we would have taken 6 to the other side and got x squared equals 6. Then we took the square root. Our answer would have been x is equal to a positive and a negative 6, square root of 6. So it would have been negative infinity up to negative square root of 6. And then negative square root of 6 to a positive square root of 6. Union. And then square root of 6 to infinity. It wasn't, but if it had been, and how I did that is here's my negative square root of 6, here's my positive square root of 6. And that's what that would look like. Okay. It wasn't, but just in case this had been a minus, because you might come across that in your homework. Okay. Now here, however, this one gets a little bit harder. All right. So what we're going to do is we've got to worry here about what numbers are underneath that radical. Because again, it's got to be positive. So let's, before we get started with this, we need x plus 4 to be greater than or equal to 0. Again, we can take the square root of 0 and we can take a square root of positive numbers, just not negative numbers. So that's why it's greater than or equal to 0. So I'm going to take the 4 to the other side because it comes at negative, because I'm going to subtract them. Okay, so on this one, my restrictions is x has to be greater than negative 4. Here, this cannot equal 0. So if I take the 3 to the other side, x cannot equal 0. Okay? So it can be anything else but that. So now, when you take your domains, you have to go back to this original one. Now we'll get to it in just a second. Let's first subtract the 2. So we have our f of x, which is the square root of x plus 4, minus our g of x, which is 5 over x minus 3. And we can leave this answer like this. We do not need to find our common denominator. It's just going to look a lot messier than it does now. Okay? So, now, to find the domain, this one's a little tricky. You want to take the most restrictive of these two. We're going to combine them. But the more, this one is any number on the number line, any number out there, except for 0. Okay? This one is, here's negative 4. It can be negative 4 and it can be any number larger than that. So the more restrictive one is this, because it's only negative 4 and larger. This one's everything except for 0. Now, if we're going to combine these two, what we have to do is we've got to take this 0 out. You take the more restrictive one, and then you kind of combine these. So really, there's a hole there at 0. Okay, so we do not have, can't be filled in because I'm combining them. So how do we write this? Well, this is negative 4. It's filled in. We go from negative 4 to 0. And we've got to take 0 out, so we're going to make it a parenthesis. Then we're going to pick up on the right side of 0, and we're going to go to infinity. So that is our domain for this one. Again, you start with the most restricted part, and then you combine it with the other one. All right, this one right here, we're going to multiply. We're going to say f of x times g of x. So we have the square root of x minus 4. I don't know why I put this in parentheses. times 5 over x minus 3. Now this one here, we can make it look a little bit better than this. This is really over 1. When we say 5 times that, we get 5 times the square root of x minus 4. All over 1 times x minus 3 is x minus 3. So our new function is f times g of x. Now, the only thing is now, gosh, I messed up. And y'all didn't tell me. That's because it's a video. I knew, I was like, wait a minute, where did I get 0 from? I'm sorry. Up here, I was so into doing this, meaning it can't be equal to 0. Here, my x can't equal 3. So this is really a 3, not a 0. So all it does is it changes this. Okay. Sorry. So again, still this is the more restricted one, and it can't equal 3. So I started with all the numbers larger than -4, but then I took out a positive 3, because if it was 3 minus 3, that gives me 0. Sorry about that. I caught it right here, because I was like, oh. All right. Still the same thing. X, I would only be looking at this denominator. X can't be equal to 3, but we already have accounted for that here. So again, the most restricted one starts at -4. It goes to 3, and to take out 3, we make a parenthesis here. That's this part right here excludes 3. And then it goes to infinity. The only thing we got to make sure is that we don't have to add any more restrictions. So right here, we're going to divide them. We're going to have our f of x is the square root of x minus 4 over our g is 5 over our x minus 3. Well, we don't like this. We learned this in our prereq section. We've got a fraction within fraction. Well, I can rewrite this as x minus 4 divided by 5 over x minus 3. Well, we never really multiply fractions. Okay, we keep the first one, and this is really over 1. Change division to multiplication and flip the second one. Okay, so now all I have to do is clean this up. Okay, and just put it over. So I'm going to have this square root. Actually, let's rewrite it like this. I'm going to put this first. X minus 3 times the square root of x minus 4. That really doesn't have to have parentheses around it. But 1 times 5 is 5. Again, our denominators, we don't have a letter in our denominator, so we don't have to exclude anything that we haven't already. Okay, that's our domain. Again, take the most restricted and combine the two. Okay. Function composition. Another way of combining functions together is to plug one function into another, which is denoted this way. You can read this. This is f open circle of g of x, meaning f of g of x. So again, you can read it two different ways. F of g of x or f open circle g of x. Basically, you're taking your g and you're plugging it into f. If it's denoted this way, it's g open circle f of x, meaning g of f of x, where you take your f of x and plug it into g. Okay. So we've got two things here. We're going to do our f of g of x. What this really means, okay, I'm going to do it the math way, and then I'm going to do it how I do it, or explain how I do it. what this really means is I take my f and I plug my g of x into it. Well, again, I take my f of x and I'm going to replace my g of x right here, which is my input of x squared plus 6. So now what I do, this is my input into my f, okay? So I'm going to take out my x and I'm going to replace it with this here of x squared plus 6. Don't forget about the minus 7. I see that all the time. So I'm going to distribute this 3. I get 3x squared plus 18, because I'm distributing 3 times 6 is 18, minus 7. Now I'm going to combine my 18 minus 7. So I get 3x squared plus 11. That is my new function, f of g of x. Now, that looks a lot harder than it really is. In reality, what we're doing is we're taking this and we're plugging it in there. So I have 3 times that x squared plus 6 minus 7. That's all we're doing. Do you have to do all this? No. That's just the math teacher, mathematics way of doing it. Okay? So no, you do not have to do it that way. So again, now we're going to do this g open circle of f of x. So I am going to, so basically what we're doing now is I'm going to take this and I'm just going to plug it in there. Okay? So it's really saying g of f of x. Okay. So I'm going to take out my f of x. My input is my f of x, and my input is 3x minus 7. All right, so that means I take my g function. My g function looks like this. So I'm going to take out my x, and for x, I'm putting this in for it. So what I'm doing is I'm replacing this x with 3x minus 7. So I have 3x minus 7 quantity squared plus 6. This here, guys, when you do FOIL, 3x minus 7 times the quantity of 3x minus 7, you're going to end up with 9x squared minus 42x plus 49, and it's running into my hole punch, plus 6. Don't forget about that plus 6. Okay. Now again, you can just use FOIL, 3x minus 7 times 3x minus 7 to get this, which gives us 9x squared minus 42x. Oh, I cannot do this right. And then I'm going to combine that to get 55. And that's my new function, g of f of x. Okay, so if you ever see anything like this, you take your g and you plug it into f. If you see this, you take your f and plug it into g. And that's what I did on both of those.